Welcome to Next Level Carpentry. I'm Matt Jackson, and I'm out in the shop today doing what I call extreme custom cabinetry. The reason I call it extreme is because one section of these cabinets I'm working on needs to roll horizontally for access to the various compartments. The cabinets are floating, so they can't roll on the floor with wheels, so they have to hang on the wall yet still move horizontally. So I've devised a horizontal rolling track system to get that job done, and because of the amount of weight involved and other constraints, I've found it necessary to use steel to make the hardware rather than trying to conjure it up with wood and wheels or cables or anything. Just like with woodworking projects, one of the first steps for steel fabrication is to cut various pieces to length. So I thought I'd shoot this quick video to show the saw I use for making clean, accurate cuts quickly in solid steel before I go on for drilling and welding and other fabrication of this process. Probably the simplest and most straightforward way to make something like this is with a cutoff wheel and a handheld grinder. That's pretty quick and easy. The next step up from that would be to use an abrasive chop saw with a 14-inch abrasive wheel typically. It's used much like a miter box for basically grinding through the metal. I do enough of this sort of work and require a level of precision in the cuts that are difficult to achieve with a handheld grinder or even the abrasive chop saw. So I've invested in a Milwaukee Dry Cut saw, and I wanted to do this quick video to show you how amazing this machine is in case you've never seen one before or aren't aware that they exist. I'm putting big red caution flags here, user discretion advised warnings in this video. The dry cut saw has a carbide tip blade. It operates much like a regular miter box, but the RPM of the saw is considerably slower. It's a special blade dedicated for this sort of work. And I will tell you frankly, I am borderline scared of this saw. I've used it for thousands of cuts without a problem, but it's got my full attention every time I pull the trigger on that saw. With a piece of wood, if the saw grabs and throws a piece of wood, there's not much inertia there, not much mass, and the edges aren't that sharp. With this saw, anything that would get out of control is probably going to inflict some serious injury in an instant. So I use it with respect, I use it with caution, but I do use it to get excellent results for this sort of work. In this ground level view of the saw, you can see it has a carbide blade, many teeth, special grind and hook angle on the teeth. The RPM of the saw is different than on a power miter box. It's slower but fast enough to be a little bit scary when this thing is running. It has an adjustable fence for angle cuts and a locking clamp for holding the work in place. That is absolutely essential. With the force that's transferred from the blade into the piece, it could really toss it and cause havoc if there was a problem there. Most of the chips are gathered up in this little tray underneath, but an awful lot of them don't make it in there also. And because I don't use this saw all the time or that often, I just put a little backstop there to kind of keep the chips in a general area so I can sweep them up or gather them with a magnet later. There's a spark deflector here. Obviously, safety glasses, ear protection, that sort of thing are required. But because the saw is actually cutting steel instead of burning its way through or grinding its way through, it doesn't generate the sort of smoke that comes off of an abrasive wheel setup. And it's a dry cut saw, so there's no cooling or lubricating fluid or a pump or a collector that needs to be dealt with. I use a support block to keep the metal level with the table of the saw. And for a wide, flat piece of steel like this, I'll clamp it in at somewhat of an angle so that the blade encounters a shorter cross-section of the steel as it's cutting, but not so steep that the clamp isn't able to hold it in place. Making sure that it's solid in there, line up the blade with my cut mark, because if I lay the piece flat like this and plunge the blade down in, it takes a while for the blade to cut through such a wide, flat surface all at the same time. It generates a fair amount of heat and it's slow to get through that piece. In essence, it's like cutting a 4-inch square billet of steel. But firm clamping pressure allows the saw to cut a shorter section of metal at a time and makes the cut quicker and smoother. With earplugs and safety glasses in place, I'll make this cut. I'm applying smooth, even, consistent pressure, making the cut, but not so much that I'm forcing the saw, but not so little that it doesn't allow the saw to make a smooth, aggressive cut. I made that cut in real time so you can see the cutting speed. I hope the saw will focus on the cut. It's just nearly flawless cut. There's a sharp burr on this side, which I can wipe off with an abrasive disc on a handheld grinder, but the cut is clean, square, both directions, true, and fast. I've got one more piece of this flat stock to cut for the other rolling track for this cabinet hardware. Second verse, same as the first. Clamp the steel in at an angle, line up the cut. Once everything is in place, make a smooth, even cut with consistent pressure, not forcing the saw or cutting so slow that it generates excess heat. It's important to allow the saw blade to come to full speed before engaging the work. As with any saw and any cut, you need to find the sweet spot to allow the saw to do the work. In slow motion, you get a better idea of what that saw is actually doing, but I've picked this piece up right away, and it's warm, but it's not hot. If I was to cut that with an abrasive wheel, this piece would turn blue in the cutting process. Both sides of the cut are this smooth, but this piece is just a little bit easier to pick up and show in the camera. With that kind of cut and performance out of the saw, I'm able to get more precision in the work that I'm doing by having pieces that are cut cleanly, accurately, and quickly. It's equally important to make sure small pieces are firmly clamped as it is to clamp the larger pieces. I'm stacking these two pieces of angle iron. When I clamp it, I make sure both pieces are firmly gripped. If one is tight and the other's loose, I'll cut them just one at a time. I'm making this cut just to clean up and square up the ends of these pieces of angle. Again, and maybe even more importantly so with small pieces, make sure the blade is up to speed before engaging the work. I like to use these silver welder's pencils for making marks on steel. They're expensive and they make a decent mark, but at least the lead breaks easily in use. I really like the quick release feature of this clamp on the saw. It allows for a quick transition from wide pieces down to the small ones like these. Small round rod or pipe is better cut individually because it's difficult to get two pieces to clamp tightly at the same time. But clamping and cutting is so quick that it hardly makes a difference. Hear that ringing? I need to know for whom the blade tolls. I'll emphasize here that there's no amount of speed or accuracy or convenience or whiz-bang or anything that's worth a debilitating injury. Injuries stay with you for the rest of your life. All this work, any of that stuff is temporal. I did want to show the way I go about this and what's possible, but make no mistake, I'm not recommending this for anybody that's uncomfortable with it, because discomfort at a certain level is just plain dangerous. Another completely acceptable option would be to measure up the parts and plan out the cuts and the holes, and then just take it to a steel fabrication shop and have them fabricate these parts. I could also do a design, come up with a working drawing for this, take it to a steel fabrication shop where they do this all day, every day, and they could make this hardware for me. But once in a while, I really do enjoy getting into a bit of extreme custom cabinetry. With this camera view, you can see how the piece of 3/8 rod is welded onto one leg of the angle, and then the other leg of the angle is welded to the back plate. This arrangement would be difficult to get with wood, but it's pretty simple and straightforward with welded steel, and it's also why I like cutting these pieces with the dry cut saw, because everything comes out so smooth, clean, and accurate. If you're curious, this is the type of roller that I'm using. The pulley is for 3/8 inch diameter rope, so it rolls nicely on a piece of 3/8 inch diameter rod. I've got one pulley screwed to a mock-up back panel of the cabinet. This will be the bottom cabinet and the lower track. So when the cabinet's set in place on the track, both upper and lower tracks, rollers will guide that cabinet to roll smoothly and easily. Because I was able to make this with steel, I was able to limit the distance from the face of the sheetrock to the back of the cabinet to about 1.25 inches. This is also why I chose to use countersunk head Tapcons to hold the track in place so that there's no bolt heads to interfere with the wheel rolling past. I could keep this angle minimal to maximize strength because I didn't have to move the rail out to account for clearing bolt heads. And with this hardware, like the end of your nose, 1/8 of an inch makes a big difference. I wasn't sure how far I'd get with this project before wrapping up the video, but here's a picture of the finished track with a coat of Hammerite paint on it and a shot of the hardware rolling on the track. This should be pretty sweet. That wonderful heater just kicked on, so my audio's probably goofed up here. I guess I'll just wrap this up and say I hope you found this little bit of insight into extreme cabinetry interesting, if not useful. If you like this sort of thing, I hope you'll consider subscribing to Next Level Carpentry if you haven't already. In the meantime, I'm going to get some holes drilled in this, finish my fabrication, and weld up this track, and just hope my plan is as good and functional as I think it is. As always, for now, thanks for watching. Go, Resner, go! So I thought I'd just shoot a short section of the video. I thought I would shoot a short section of video to show the saw off for cutting this plate.